Assalamu alaikum, my dear students. I hope all of you are fine and doing well. So, the topic here that we are going to discuss today it is the oxidation state of transition elements. Basically, the word oxidation state mean the simple number of electrons that an atom can donate or that it can accept from a bond formation with another atom. It is called as its oxidation state. On the other hand, the oxidation state can also be defined as it is an apparent charge that an atom can have in a molecule or in a compound. So it depends upon that what type of the molecule or the compound is present, whether it is present in the form of ion. The charge is basically called as its oxidation state or oxidation number. So it depends upon that how many number of electrons that an atom has donated or loses, or how many number of electrons that it has accept or gained for the formation of the bond. That depends upon its oxidation state. Now here we are going to discuss the oxidation states of the transition elements. The transition elements are basically called as the D block or F block elements, in which the D block elements are called as outer transition elements. On the other hand, the F block elements are called as inner transition elements, and these transition elements are also called as the B group elements as well as F and D block elements. So here they are going to be start from the B group from 1B to 8B. All are called as the transition elements. Now what will be their oxidation state? There is a simple variation in their oxidation state. Let's have a look on this. We just discussed the first series of these transition elements, in which first one we have titanium. It can exist in three oxidation state, or it can shows up three oxidation state while having the bond with the other elements. Like it can have positive 2, positive 3 and positive 4 oxidation state. Likewise, if we talk about the vanadium, it is also a transition element and it can exist in the positive 2, 3, 4 and 5 oxidation states. So it can have total 4 oxidation state. Titanium has 3 oxidation state. Then we have chromium. Chromium can exist in positive 2, positive 3, positive 5 and positive 6. So it again has 4 oxidation states. Likewise, if we talk about the manganese, it can have 5 oxidation states like positive 2, 3, 5, 6 and up to 7. On the other hand, iron, which is also a transition element, it can exist in 3 oxidation state plus 2 plus 3 as well as it can have plus 6. When it is making up the compounds ferrous, then it shows plus 2 oxidation state, but on the other hand, when it is making up the compounds like ferric, then it shows the positive 3 oxidation state. Then we talk about the cobalt, its symbol is Co. It exists only 2 oxidation state plus 2 and plus 3. While likewise the nickel it can also shows the plus 2 and plus 3, and copper it can have 3 oxidation states like plus 1, plus 2 and plus 3. So this is the simple variation in the oxidation states of all these transition elements. Basically when they just shows the plus 2 oxidation state, it's mean just 2 electrons are involved in the bonding, and in their highest oxidation state of all these elements, if we talk about the zinc, which are as a non-typical transition element, it shows oxidation state which is positive 2. Likewise, if we have already learned about the oxidation state of copper, plus 1, plus 2 and plus 3. So this is the simple examples of the oxidation state of the 3D series, that mostly they shows the positive 2 and plus 3 oxidation state all. On the other hand, there is just one that can shows plus 1 oxidation state. Likewise, iron can also have plus 1 and manganese can also have plus 1 oxidation states. After this, we have colors of transition elements. Basically, transition elements are the elements. Basically, these are metals when their metal ions are present, they shows different types of colors when we have their aqueous solution. Likewise, if we talk about the titanium, its symbol is Ti. When it is present in positive 3 oxidation state, it shows the color purple. So from that purple color, we can be able to recognize that it is a titanium. On the other hand, when we talk about the vanadium, as it shows 4 oxidation states, when it is in the plus 2 oxidation state or in the complex form, it shows plus 2. When it is in the green, plus 3, in the sky blue, plus 4, and when it is yellow formation of the crystals or the solution, its oxidation state will be plus 5. Likewise, if we talk about the chromium, its symbol is Cr. It shows 3 oxidation states, plus 2, plus 3, and plus 6, and respectively it shows the color blue, green, and then orange. If we talk about the copper, it exists in positive 2 state and it shows that color, which is the sky blue color. Likewise, if we talk about the nickel, it shows positive 2 oxidation state in green color. And when we talk about the cobalt, plus 2 oxidation state, it shows pink color. And here we have iron. It exists in 2 oxidation state, plus 2 and plus 3. And it shows color from green to yellow when there is a change in the oxidation state. And then we have last one, manganese. Mn oxidation state, it shows color from light pink to dark pink from plus 2 to plus 7 oxidation state. Now, what is the main purpose or what is the benefit for this color change? It is very simple. From their color change, we can easily be able to identify that which one of the transition element is present and in which oxidation state. So this was a simple topic that we have today. I hope you guys understand, and if you have any queries, you may ask me about that in the comment section and I will get back to you guys soon. And the next topic that we will discuss, it is very simple topic, complex compounds that is related to the transition elements. For that time, you guys keep learning and have a good day.